I want to give you a little bit of a sneak preview into the kind of applications we will actually be deploying in part 3. In order to do that, let me start off by reminding you about the ML workflow. If you recall from course 2, the ML workflow is all about how you collect your data, how you pre-process your data so that you can then prepare that data to be ingested by a neural network that you're designing, which you're going to train using tools like TensorFlow, and then evaluate both the performance and the accuracy. And when you're happy with it, you will use a converter to actually convert the model into something that can be deployed into a wide range of devices, be it on a mobile device or a microcontroller. In this particular course, we'll focus a lot on deployment aspect of things, which we are yet to cover. Because in part 1, we focus very much on helping you understand how to actually design a model and how to train a model. And we gave you the pre-existing data sets so that you could bootstrap from that. In part 2, we took it all the way from collecting your own data to actually deploying the model or coming close to deploying the model by actually doing the TF-Lite conversions. In part 3, we're going to spend the entire gamut going all the way from collecting the data to actually deploying the converted model into an embedded microcontroller and actually making inferences. And the way we're going to do that is by physically deploying the models into an embedded microcontroller that comes coupled with a couple of different sensors that will allow you to have the full experience. Now, this kit that I will talk about in more detail in the upcoming videos is going to be really awesome. And this is one of the really interesting things about this kit is that while there's a hardware portion coupled very elegantly with TensorFlow Lite for microcontrollers, this is a state-of-the-art inference framework from Google. Using this setup, we're going to help you cover the ML workflow. Specifically, we want to help you understand how to build applications like keyword spotting, which a lot of core fundamental attributes, in terms of engineering a solid end-to-end pipeline. Now, you might be thinking, hey, yes, I know about keyword spotting. I've heard about it in part 1. And hey, in part 2, I did train a small spotting model. But hey, what do I need to know now? I'm going to tell you here that is much, much more than just getting the model right. I hinted at this in part 2, but when it comes to actually deploying the model on the device, you really have to think about where's the audio stream coming from. It's not on a file on your computer. It literally streams in from the input sensor. And how do you couple that input sensor with your neural network and make sure all these things run in a timely fashion? And there's also the aspect of post-processing. And some of these things might seem new or a little complicated, and yes, they should be because these are really new concepts. So we'll talk about that. While dealing with an audio sensor is interesting, with visual wake words, we dealt with a camera, and that was interesting too. Both were just single sensor applications. But hey, that's not it. We're actually going to focus on taking the audio sensor and the visual sensor and do sensor fusion, where we can actually run 2 models together so that you can actually do audio visual recognition. In other words, how can I get the machine to respond only when it recognizes that I'm physically in its space? Which is going to make the TinyML device much more intelligent. And in showing this application, there are a set of fundamental new things or concepts that we're going to teach you about, like model multi-tenancy, which is very important and rarely talked about in TinyML. And that's one of the upcoming areas that's creating quite a lot of value and buzz. Finally, we'll expose you to this super awesome and exciting application called the Magic Wand, where you'll move the device in thin air, and then you can see in real time the device recognizing what you're actually doing. For example, here, the machine will actually recognize the letter Z. And this sort of gesture recognition capability has many different applications in many different areas, especially in biomedical applications. So more on this later. So I'm very excited to be talking to you about these different applications. One of the things that we will do is go all the way from understanding the characteristics of the sensors, learning how to couple them onto the embedded device, which is then running the neural network and learning how to assess whether the neural network is actually performing well or not. And that is going to give you an end-to-end picture, which is extremely important to be a good TinyML engineer. And that said, I'll see you in the next video where I'll actually introduce you to the kit.